I have to make a chemistry presentation to graduate high school, and I thought that I'd record it too.
So, jobs are boring. I'll say it. Like back then, you could work at 6 years old, climb down some chimneys, and get cholera. But nowadays, everyone's some sort of stupid associate or something. And that's silly.
So, I say, instead, we make iron. In my opinion, it's a mid-metal. Like, it's above zinc, but below silver.
But a lot of iron is used. Like 93% of everything mined just straight up is iron. People want it. The average person indirectly buys over 200 kilos a year. Not from people going to the iron shop and buying like some iron ingots for the kids, but through the government wasting our taxes on steel bridges and buildings and such. I mean, just look at this graph again. Like, literally no one cares about the other metals. And people are going to want it into the future too. It's great. So, we take iron ore and turn it into elemental iron. But what is iron ore really? It's iron oxide. So, the iron is oxidized. Big surprise there. That means we have to reduce the iron. Because chemistry, that's just opposite of oxidized. Whatever, don't worry about it. What we need is a reducing agent. And there are two of those that work in this scenario. Hydrogen and carbon monoxide, CO. CO is sad and stupid because when it reduces the ore, it turns into CO2, probably one of the worst gases out there.
But when hydrogen reduces the ore, it transforms to H2O, which is great because that's water.
The problem is, most people use CO to reduce their ore because you get it by heating coal with steam, and coal is super cheap. Hydrogen, on the other hand, okay, look, you can get it by treating methane gas with steam, but that's cringe, okay? So I'm gonna pretend you can only do water electrolysis, and that's splitting H2O into H and O. At first look, it might seem cheap because water is so common, but the real cost here is the energy that needs to get put in to split the water up. Like, water really likes being water. It's very stable. That's why humans are 60% water and not like 60% gasoline or something. Water doesn't do anything other than being a good medium for reactions to happen, which is good. So in the end, using green hydrogen ends up making the whole thing 20% more expensive. But I mean, honestly, the way things are going for energy prices, it seems like soon enough, energy prices are going to drop enough to make this competitive. And like, as the capacity gets built out anyways, it's going to be even cheaper, it's going to be fine, okay? So I'm just going to use hydrogen for the rest of this. So back to the main thing. We put the iron ore in the top of a really hot furnace and pump the hydrogen in the bottom. As the ore slowly sinks due to gravity, the gas flows up because that's what hydrogen gas does. It's really light, so it goes up, right? Like bubbles. Like when you blow bubbles underwater, they go up because it's lighter or less dense than the water around it, right? And at the bottom, pure-ish iron falls out. And that's money right there. If the ore costs $60 per ton and the product, it's called sponge iron, whatever, sells for $150 a ton, and even compensating for the loss of the oxygen atoms and the impurities, is still a big difference. I just have to sell about 10 million tons of it, and then I'll have $1 billion. Boom, title, fulfilled. I don't care, you're watching a chemistry video now, okay? So we're looking at this reaction between iron oxide and hydrogen gas, but really, it's a process with multiple steps. There are intermediate products that represent oxidation states of iron in between +3 and 0. And God thought this shit's too easy. So he made turning FeO, iron 2 oxide, into pure iron by far the hardest step. It's cringe. The name of this compound is wustite, more like wussy-ite. Anyways, this reaction is happening in a 3D world, right? To all the pellets. It's like a ball of ore being attacked by the hydrogen from all sides. The gas comes from the outside, absorbs into the pellet, and slowly reacts the outer to inner layers to pure iron. And of course, the produced water then makes its way out of the pellet. And that's just how it works. This causes some things to be important. In general, in a reaction between a solid and a gas, which this is, you can kind of always say that the diffusion of the gases is the rate limiting step. It's the slowest step in a series of dependent processes, and that pretty much means if we get the hydrogen to the pellet faster, the whole reaction happens faster, which is good because of money. So now the question is, how to make the diffusion faster? To do this, we can control two things, the pellet size and the temperature. For the pellets, right, there's an argument to make them as small as possible. The smaller they are, the bigger the total surface area is, which means that more hydrogen contacts more iron oxide, which causes the reduction as a whole to happen faster. That would mean a super fine sand would be best then, right? Because maximum surface area? It turns out though, that in real life, they use around pea-sized pellets.
This is because if you have a dense wall of powder, the hydrogen can't budge its way through it. You need small gaps in between the pellets so that the whole stack of material can react with the gas. Now, temperature. If it's higher, the chemicals react faster. Who would have thought? But if you turn the temperature too high, around above 900 degrees Celsius, look, it doesn't melt, but the atoms on the surface of the pellets fuse together because of sintering. Sintering is like almost melting, but just on the outer surface of the pellet. Overall, it causes the pellets to clump together and form a dense, homogeneous mass, which doesn't let hydrogen through. So the outside gets reduced, but the inside is still completely undercooked. In total, hydrogen is great, the pellet size is important, and the temperature should be high, but not too high. And this is only one way to get iron from iron ore. There are about 1 billion other ways, and I didn't even talk at all about steel making, which is a whole other thing. But look, I just want to survive this 10-minute presentation, and I think this is going to be about enough. And either way, I submitted 2 topics to present, and they're going to choose one. And this is only one of the topics, right? So I'm going to do another quick video on the other topic, just to not put all my eggs in one basket, you know? So subscribe if you want, I don't care.